to the next installment of the cyp-c Research Champion webinar series. Today, we're having Giancarlo speak to us about cleaning data using SAS, and it will basically follow on some of the previous webinars that we've had looking at how to use SAS to actually undertake an analysis using the cyp-c data. So just a bit of background, Giancarlo is a research associate and analyst here at the Pediatric Oncology Group of Ontario and works with various cancer databases here in my research program, and he generously agreed to develop and deliver this talk today. So I will pass the mic over to Giancarlo, but I think first Randy will mute everyone's mics. We'll have Giancarlo deliver the presentation, and then at the end we will unmute everyone so that they can ask any questions that they have. So Randy and Giancarlo.
All right. Thank you very much for that introduction, Jason. So this week's talk, the title of the talk is Dirty Data, Clean It Using SAS, an Introduction to Data Cleaning Principles. So here I've outlined pretty much what the talk is going to encompass. We're going to revisit what we've learned so far in terms of a SAS overview and the procedures within SAS. And then I want to dive into the fundamental principles when building a clean data set. And then I want to discuss using your inclusion and exclusion criteria to clean your data, and then from there visualizing what the data looks like and the distribution, identifying any outliers that may be contained in the data, and then how we handle those. And then we're going to look at cleaning character variables, and then we will discuss some missing data and how to deal with that, as well as creating data checkpoints, which is a very important process when you are cleaning your data. So a brief overview of what we've learned so far. For our purposes, there's really only two main things we can do within SAS right now, is a data step and a procedure step. So within a data step, that's how we manipulate our data. We read in the data, we create and redefine variables, we subset it, we assign it formats and whatnot. And then there's also some procedure steps where this is when we really analyze the data and see how it's distributed, and that's how we run our regression models. When we're performing data cleaning, we use both data steps and procedure steps. And in our last lecture, Jason covered the different SAS procedures. So proc-freq, print, means, univariate, and sort will be covered today, and there's also proc contents as well. So before I show everyone how to clean your data using SAS, I want to introduce some pretty general principles on data cleaning and why data cleaning is necessary, and ultimately it will become a major time consumer in terms of your research project. So first we need to understand why our data is quote-unquote dirty. So no database is ever initially clean, and this is because databases aren't constructed with our very own research questions in mind. My research question might be different than yours, then that might be different from the next researcher, and databases aren't really tailored or built to satisfy each individual research question. So researchers must be familiar with the purpose of the database, how the variables are captured and defined, as well as the structure of the database and when we're cleaning the data. When we do perform our data cleaning, it's essential that we have an analysis plan set out. So I like to think of it as, you envision what your analysis data set will look like, and then you work backwards. So, we know we want a regression model and certain categories in our exposure variable. So this will help us when we actually perform the data cleaning and assigning formats and groupings. However, it's really important that we determine what the study population denominator is before we perform the data cleaning. So it could be patient population, so only one record per patient, or it could be, our research question could involve multiple diagnoses where we would have multiple entries for each patient. Or it could be person time. It could really vary, and this is based on our research question. Now, a lot of people are under the assumption that data cleaning and data manipulation are completely different entities, and I'm here to tell you that it's really a simultaneous process. Data cleaning and data manipulation go hand in hand almost. Both can and should be performed within a single data step. And this really ensures efficient programming and it makes a program that's easy to follow if you decide to come back to it a week, a month, 6 months, a year later. So you can really follow how you're manipulating your data and how you're actually cleaning it. So let's dive into how we first start off cleaning our data. I like to start off by subsetting the data. So we initially receive our data cut. Most researchers are guilty of this, where we like to request slightly more data than what's actually needed. This gives us a little bit more wiggle room in terms, if our hypothesis may change slightly. A little bit more data is better than not enough. But no data cut's ever really perfect. The data still needs to be cleaned. When we initially receive our data cut, it's never ready to be analyzed right away. It first needs to be cleaned. So how do we do that? We start off by cleaning our data using our inclusion-exclusion criteria. So in this example, I'm going to propose a theoretical research study, and I want to look at the survival due to the influence of white blood cell counts in children with leukemia. I'm only concerned with the child's first cancer. So I sort a previous database, here I call it T7, by cyp-c ID, and then I sort it by diagnosis date. And then I output that sort to a data file I'm calling T7_sort. From last lecture, we learned that SAS will sort the observations first by the cyp-c ID, and then it will sort by the diagnosis date. So for patients with multiple diagnoses, the earliest diagnosis date will be at the top. Since I'm only concerned with their first diagnosis, I'm telling SAS here that I only want you to take the first observation you read from the T7_sort database to be in my new database, and I'm naming it T8, and that's based on the cyp-c ID. If you see more than one cyp-c ID, which is possible for patients who get diagnosed with more than one cancer throughout their lifetime, I don't care. I just want that first diagnosis of cancer. And I know that I'm selecting the first diagnosis of cancer because I've already sorted by diagnosis date in the previous sort command. Another inclusion-exclusion criteria for this theoretical study is that I'm only interested in children between the ages of 0 and 14 years old, which is what I'm telling SAS here in this statement. I only want you to select kids equal to or greater than 0 and less than 15 years. So therefore, kids aged 14.9 would also be included. cyp-c databases include kids only in that age range, but it's also a good data cleaning practice to put this line of code in there, just in case any kids over the age of 14 may have slipped through the cracks and were included in the data cut. I'm now going to introduce a powerful SAS command called the if-then-else statement. And it's a little bit tricky to understand, and if done improperly, can lead to misclassification errors. My plan here is to create categories based on diagnosis age. So I start off by telling SAS that if a child is between the ages of 0 and less than 1 year, then I want you to create an age grouping called dx_age_group and assign them a value of 1. This would create a group of kids with the age ranges ranging from 0 to 0.99 years old. Once it is assigned a value of 1 to the age grouping, to those kids who met the conditions, SAS now considers them an assigned observation and puts them aside to prevent further processing. I then continue with the next line of code saying, else if the child is less than 7 years old, assign them an age group value of 2. Now this is crucial here, because this group contains children aged 1 to 6.99 years old. It does not capture the kids less than 1 year old, because SAS has already assigned those kids age grouping value of 1 from the first line of code. And once those conditions are met, it no longer processes those observations in subsequent else statements. The same principle applies to the next line of code, which will put children aged 7 to 10.99 into age group 3. I close the argument now by saying for everyone else, give it an age group value of 4. So now all the leftover unassigned observations, which haven't been processed in the previous if-then-else statements, are now assigned an age grouping value of 4, meaning this group contains kids aged 11 to 14.99. Had I not ran the age inclusion criteria code, so the 0 less than or equal to dx age less than 15 line, then if kids were missing diagnosis age, were 16, 17, or 18 in the data set T7, then that final else statement would have wrongfully included them into my 4th age grouping, and I would have thought that these kids were aged 11 to 14.99. I then label my newly created age grouping variable and apply a format to know what each number represents. And here's a good example of a data cleaning principle and data manipulation done simultaneously. I'm also only interested in kids who were diagnosed between 2002 and 2012. So I use the year command on the diagnosis date variable. And it's important that the diagnosis date variable is formatted as a date. Once I've selected those kids diagnosed between 2002 and 2012, I'm also creating a year variable, so dx1_year, where I'm pretty much extracting the year of diagnosis from the diagnosis date variable, and I'm using that just in case I decide to do any trend analysis. And since I'm only interested in leukemia cases, I'm telling SAS if the ICC main diagnosis category is equal to 1010, or the ICD-OM code is equal to those, I want them in my data set, because that's what I've determined as a leukemia. Also, you should note at the bottom of my data step, in the little notes section, I've kept a log of the sample size. And I like to do this because it's really good data cleaning practice to keep, between different data steps, you might be adding observations through merging or deleting, and it's really good to follow what your sample size is doing in each data step. And you can determine that from the SAS logs. It will tell you how many observations are in the T8 data set after you run the command. So once I've subsetted my data, I want to now look at how is it distributed. And we can recall from last session that the proc-freq produces frequency outputs. So you can use proc-freq on either numeric or character variables. And it's very useful for counting frequencies and proportions of a variable. However, if you use proc-freq on a numeric variable, it treats it as a nominal variable where each number is a quote-unquote group. So depending on decimal places, 9.9 will read differently than 9.90, even though they're the same numeric value. And then we also learned that proc-means and proc-univariate are commands within SAS that will look at numeric variables and the data distribution. This is really powerful for data distributions and the normality of the data. Once I've subsetted my data, I always run proc-freq and a proc-means or univariate as the first step of a data cleaning process. And that's really because it helps me understand what my data pretty much looks like. So I've decided now in my theoretical research study that since I only want the first diagnoses, there should only be one record per patient. And I'm going to check that. I want to see if there's any duplicate entries because there shouldn't be. So what I do is I run a proc-freq, and in the table command, I put cyp-c ID. And I add the slash missing in there because it's just good practice. There shouldn't be any missing cyp-c IDs, but I put it there anyways because I want to make sure. Now I add a new command that we haven't seen before, the order equals freq. And what the order command does is it will order the output by the highest frequencies. So the variable value with the highest frequency will be at the top of the output, followed by the next highest, and so on. So in this scenario, if there were duplicate patient entries, they would show frequencies greater than 1, and they would be at the top of my output. But I can see here that I don't have that because I've already cleaned my data, and I've used the first .cyp-c-id command. I would expect there to only be one record per patient, which is exactly what I see, which is good. Had I done merging improperly, let's just say, for example, cyp-c-id 10050 was in my data set 3 times, it would now be at the top, and it would show a frequency of 3. Now I move on to my continuous data. I want to see how is it distributed. So I always use proc-univariate first because I feel proc-univariate is a very thorough procedure command within SAS. It tells you a whole bunch of information. So I tell SAS, I want you to do a procedure univariate on data T8, and I want you to check for normality. The variable of interest is my main exposure variable, which is the white blood cell counts. I also add the ID statement in there, and I put cyp-c ID. And if we can recall from last lecture, that is an identifier command. And it only works in this situation because there's one record per cyp-c ID. If there are any duplicates, SAS would give you an error and this wouldn't run. ID is very useful in the univariate output because it's used to identify any extreme observations. And then I also tell SAS, I want you to create a histogram for me of the same white blood cell count. And I'm going to use the /normal command because I want you to overlay a normal curve on top of the histogram. Now, I've also included the ODS graphics on command before I even run my procedure command. And what ODS is, it stands for Output Delivery System. And it's a built-in system within SAS that's useful for creating nice-looking graphs. So by having that command in there, I'm telling SAS, I want you to create a high-res graphical output for me, which looks pretty. So now let's take a look at the actual distribution of our data. Three things stand out to me automatically. My sample size is only 2008, but I know from the previous data step, in my little log at the bottom in my notes section, my sample size in the cohort for T8 is 2,492. But the SAS procedure runs the univariate command on 2008. So I have just over 400 observations missing already, which is kind of making me a bit uncomfortable. Missingness is very present already. Also, I note that the mean is absolutely massive, with an equally large standard deviation. This indicates that there's severe variability going on in the data in terms of the white blood cell counts. And I start to think to myself, is a population average of 1,500 cells times 10 to the 9 per liter even possible on a population level? I really doubt it. The median is much more in line with population estimates. And this is a good example of just how vulnerable the mean is to the effects of extreme outliers and how the median is quote unquote protected from them. Something's going on here and it needs to be investigated further and ultimately cleaned. So in the next part of the proc univariate output, it tests for the normality because I told SAS I want you to test for normality. And tests for normality in SAS are done under the assumption that the null hypothesis is that the data are normally distributed and that the alternative hypothesis is that it's not. So we can see here that our p-values for normality are quite significant. So we can reject the null hypothesis and conclude that our data are not normally distributed. And then we take a look at our quintiles, or our quantiles, sorry. 720,000 times 10 to the 9 cells per liter. That's not biologically plausible, I don't think. Their blood would be so thick and viscous, it would have the consistency of molasses. This is probably the result of someone entering the white blood cell counts using the wrong units. So, we really look at where 99% of our data are in terms of the extreme outliers. So, 99% is around the 1,000 mark. So we really need to clean that 1%, which are our extreme outliers. I also note here that 95% of my data is contained within the minimum, so 0, all the way up to 323 white blood cell counts. Now we can start thinking now, what's an arbitrary number, something like, 500, as a possible cutoff point when we determine how to clean this continuous variable. And then finally, from the proc univariate output, we see here the extreme observations. So I'm really concerned with the extreme observations on the high end because that's what's pushing the mean towards the right if you think of a normal distribution. So since I told SAS I want you to use the ID command with cyp-c ID, I'm able to look up exactly which extreme observation relates to the cyp-c ID. So I know the patient with 720,000 white blood cell counts is cyp-c ID 12086. And that's because I told SAS that I wanted it to. So I can now think to myself, how I clean my data, I can individually investigate these cases, and I can go back to the data manager, and if that's not possible, then I need to deal with it myself. I also note the missingness. 484 ALL patients don't have a recorded white blood cell count. This is crucial because, especially ALL is a blood cancer. We would expect to know the white blood cell counts. This tells me that 25% of my main exposure variable is missing in my data set, and that makes me extremely uncomfortable, and I need to decide what exactly I'm going to do with this missingness. And since I told SAS I want you to create a pretty graph for me, here's the pretty graph, although it's severely skewed to the right. And we can see just how the extreme outliers can have an effect on the distribution of continuous variables. So now that we've identified our outliers, we need to really think about how we're going to clean them and deal with them. So there's many ways we can deal with outliers here. However, if there are many within our data set, and if the many are extreme, they will have a severe bias in terms of our study, as we just saw with the white blood cell counts. So there's many ways that we can handle and clean these skewed data. We can use the median and interquartile range instead of the mean, and that's because the median is a bit more protected in terms of influences of extreme outliers. Or we can use a logical range of values and assign any outlier the upper limit or the upper bound of that range. What we can also do is categorize our data based on distribution, or we can categorize it based on any clinical meaningful ranges that we determine. However, I need to stress that whichever approach is used in terms of the data cleaning should be justified and transparent. So now that we've identified the outliers, let's see how exactly we can clean them. So my first scenario here is I want to pretty much assign an upper limit to any outliers that I've identified. So I'm telling SAS, if the white blood cell count is greater than or equal to 500, then I want you to create a new variable called white blood cell count clean and assign it a value of 500. Otherwise, this new variable, I want you to retain the old white blood cell count variable. And essentially what this does is it creates a cutoff point. So that 720,000 white blood cell count will now, in this new variable, or the clean variable, will be equal to 500. Or I can also create categories. And I've thought about here creating clinical categories. You can categorize them based on what's in the literature or what clinical trial protocols use, or even if it makes logical sense. But like I said before, it needs to be justified and transparent. So here I'm going to introduce another SAS command, and it's called a do loop. So in this first line, I'm telling SAS if the white blood cell count is not equal to, and I should mention that the little triangle or the little hat is an equivalent of not. So the line reads, if white blood cell count is not equal to missing, then this is what I want you to do. So if it's not missing, then, I like to think of this as if the conditions to the left of the then do command are met, then I'm telling SAS what I want it to do. If they aren't met, then I don't want anything processed. So since I know that I have many missing white blood cell count data, I need to make sure that I deal with it and preserve the missingness while cleaning. So what I'm telling SAS is if the white blood cell count is not missing, this is what I want you to do. And here's the if then else statement again. So in the first grouping, I know that any white blood cell count from 0 to 49.99 is in group 1. And then in group 2, it's 50 to 99.999, and so on and so forth. However, when you do a do loop, you essentially tell SAS, this is what I want you to do, but you also need to tell SAS, this is when I want you to stop, or I need to close my do loop. Otherwise, SAS doesn't know when to end. And if you were to try to run this without the end command, SAS would give you an error. So now when SAS reads an observation with a missing white blood cell count, it hasn't met the conditions that I've told it in my do loop, so it won't carry out what I've outlined within that do loop. So it will not perform the if then else statement, but rather it will skip over that record, essentially because it has a missing white blood cell count, and put a missing value in the newly created grouping variable that I've now told SAS I want it to create. If we don't have that first statement in the do loop, so if we don't have if white blood cell count is not missing, then SAS will treat all those 484 entries with a missing white blood cell count and put them in the less than 50 category and misclassify them. And that's because SAS treats a missing number or a missing variable as the lowest possible number. So we will misclassify them and put them in that group 1. So now once I've cleaned my data or my continuous variable, I want to see how the distribution looks now. So I run a proc means and I tell it, I want you to give me the mean, the min, and the max, and I want you to give me the median and interquartile range. And I want to compare them to see if anything has changed. And I'm going to use the new variable I just created, the white blood cell count clean variable. And this variable here is still a continuous variable, so we can run the proc means on it. And here's my output. I can see now that instead of having a mean of 1,500, the mean is now 57 or so. So you can see that once the outliers have been cleaned, the mean has shifted a lot more to the left in terms of a normal distribution. However, this mean is still high because of the observations within the 500 count, or the upper bound of our data. And also, I want to take a look at the median and the interquartile range. And I see that it hasn't changed at all. And this just really enforces, how the mean is so easily influenced by extreme outliers and how the median is protected. So if I were to report here the white blood cell count, I would probably opt to use the median and interquartile range instead of the mean. And I also told SAS that I want you to create the histogram plot for me again. And we can see that this graph here looks much different than before. It's still skewed to the right, but not as severe. Now I also want to see, I want to compare the mean and the median and the interquartile range, and I want to see the distribution of the grouping variable that I just created. I make sure that I put the slash missing command in the proc-freq because I still want to visualize how much missing data I have and if it was preserved when I coded or not. Because if it's not there, then that will cause problems. So now we have the frequency output. I can see that 61% of my patients have white blood cell counts in the first grouping, and that first grouping represents the range from 0 to 49.99. This is more in line with what would be expected in terms of a population level. I've also noticed that I've retained the missingness in terms of the white blood cell counts, and that's only because I told SAS to skip over processing if it was missing. Otherwise, these would have been misclassified in group 1 because of the way that SAS reads numbers and missing observations. I also note that the extreme outliers are now contained within group 6, and this group only has 71 observations and represents 2.85% of my data. So now I need to ask myself, how can I further handle those outliers? Can the outliers within this group as a whole be set to missing? After all, 20% of my data is already missing with another 2.85%. Whichever approach I decide to use, if I keep them in there or if I set them to missing, again, should be rational, transparent, and justified. And now I'm going to discuss how to clean character variables, and I can guarantee that most of the cleaning will be spent with character variables because I believe character variables are the dirtiest variables within a data set. The inconsistency in terms of misspelt words or capital letters and the casing, even just entering data, it's subject to human error. From paper charts, something might be misread. There's just many opportunities for textual data to be entered wrong in a database, and it will cause a bunch of headaches in terms of data cleaning. So capitalization matters in SAS. So this is a different data set that I'll be using for the remainder of the presentation, but I want a frequency output of the protocol name. And I want a frequency output of the protocol name because I'm assigning disease risk status to ALL patients. So here is a little snippet of the proc-freq in terms of the protocol name. Now here we see that even though each of the highlighted protocols are ALL protocol C, and I know that ALL protocol C is a high-risk protocol, it's the kids. They're spelled the same, but they have different combinations of cases, and that's upper and lower case. But SAS and the proc-freq procedure reads each of these entries as different inputs or a completely different variable value and treats them as separate entities. And that's because SAS reads character variables as case sensitive. So how do I pretty much clean this variable here? Well, there's a simple command in SAS, and it's called upcase. And what upcase does, it's a slight data manipulation trick where I'm telling SAS, I want you to create all the character variables and put them in the uppercase. So now once I run the proc-freq on protocol name, it's going to give me this output. And I can see I'm still interested in protocol C, but now I notice that there's 132 observations. And that's because SAS has read them the same because they're all upcase and they're all in the same case. And that's because SAS is case sensitive. However, now I've run into a different problem. So I'm still interested in protocol C, but now that everything's upcased, I see that there's many different combinations of protocol C entries. There's protocol C dash modified, protocol C/CCG, but I only am concerned with protocol C. That's all I really want to abstract. If they got protocol C, then I want to assign disease risk. So essentially, I just want to collapse all the entries that contain ALL protocol C into a new variable so then I can determine whether the patient was high risk or low risk. So SAS has pretty neat search functions that are built in terms of searching any text variables. So this is the same command as before, so the upcase. So I'm creating a new data set, T9, and I'm using my T8 data set. And I'm making a variable called protocol name, and it's going to equal the upcase of the old variable protocol name. So it's pretty much overwriting the protocol name, but everything will be in the uppercase. But now I'm telling SAS, I want you to find something for me. So I'm saying, within the variable protocol name, I want you to find, and I'm putting it in quotation marks. And it's critical that I put what's in the quotation marks as all upcase because in the previous line, I just upcased the variable itself. So it should align with the casing. So you're going to scan protocol name, and this is what I want you to do. Now, it doesn't matter what's to the left or to the right of what's in that quotations. SAS will just find exactly what's in there, and that includes spaces as well. So I want you to find ALL space protocol space C. And then once you find that within the text, this is what I want you to do. So I want you to pretty much overwrite the variable to just ALL protocol C. So I don't care if it's modified or not. And then I also want you to create a new variable called ALL risk. And I want you to classify that as high risk because I know protocol C is for high risk patients. And that's all I want you to do. So I'm going to close that do loop with an end. And then once I run the proc-freq on this new data set that I just created, I want to see what exactly happened to my protocol name using the find command. And here is what we get. So all the different permutations of ALL protocol C dash modified, ALL protocol C space modified, what have you, it's all been collapsed into a single variable called ALL protocol C. And that's because SAS searched that variable for what's exactly for what I exactly told it I wanted, which was ALL protocol C. However, I need to stress to use caution when searching text. And that's because it can lead to many errors in data cleaning. And that's the result of the phrase that's being used. So the search term should be unique enough to prevent any unwanted matches. And I'll show you what I mean by that. So in this example here, still using protocol name, if I were to use ALL protocol B using the find command in SAS, then SAS would think that the entry ALL protocol BFM90 was actually protocol B. And that's because it doesn't matter what's to the left or to the right of the quotations. All SAS sees there is ALL protocol B. But I know that the BFM is not ALL protocol B. It's actually a European protocol. So although the find and other search commands are very powerful within SAS, the margin for error is pretty high. So search with caution and diligence. Now I want to discuss some missing data and how to visualize missing data and whether it's missing at random or not. And I can almost guarantee you that you will encounter missing data within your research projects. So we can recall from our previous lecture that the /missing options within the tables line of a proc-freq will output the missingness contained within that variable. So I'm telling SAS, I want you to create a frequency output of stage code, and stage code is a variable that's used as the staging of the disease. And I want you to treat missingness as its own category, if you will, and I want you to tell me how much of my data is missing in terms of percentages. So here we have the output, and I see that 7,500 cases, or 70% of my data, of my staging variable, is missing. However, when you're looking at your missing data, it's critical that you understand your missing data and what the story it's telling you. So here I'm telling SAS that I want the frequency output on staging, but I put a where command in there. And I put the where command in there because I'm telling it, I only want you to do the frequency output on diagnosis group 2. And I've assigned diagnosis group 2 to lymphomas because I know that lymphomas are an actual staging cancer. So in theory, I should have almost all of the staging information for the lymphomas. So SAS will only run the frequency output of for the variable staging on observations that satisfy the diagnosis group value of 2. Now I know that staging is truly missing for 534 patients because that variable is applicable to lymphomas since it's a staging disease. When cleaning, we need to look at how the missing data is distributed. Is it missing at random, or is it missing based on a variable? So it's really essential that we understand our data. In this example, the initial frequency output told me that 7,500 observations were missing, which is about 70% of my data. But these are not truly missing because staging isn't done for leukemias and the other pediatric cancers, which represent the majority of childhood cancer. It's critical to know that missingness versus not applicable are not the same. We need to know the difference and when each scenario is applicable when looking at missing data and determining how we actually clean it. So once we look at our missing data, it's good to create data checkpoints when we are actually cleaning. So first, I want to create some date checkpoints. So in this command here, or in this date checkpoint, I'm telling SAS that I want you to create a new data set. And this data set, I'm labeling as flags. And I label it flags just so I know that this is a data set that I'm using to flag any dates that don't make sense to me. And I want you to use data from data set T8. And in the brackets, I only want patient ID, date of birth, diagnosis date, and date of death. All the other variables don't really mean anything to me, or I'm not interested in them. So I do a keep command, which will keep only those variables from the data set T8. And then what I tell SAS is, if the date of death is before the diagnosis date and the date of death isn't missing, then I want you to create a new variable. And that new variable is, I'm labeling it death flag. And I want you to set it equal to 1. Otherwise, I want you to assign it a value of 0. And what the death flag represents are patients who died before their diagnosis was made. This is possible because you can be diagnosed with cancer post-mortem. I also want to create another flag. And this flag is, if the diagnosis date was before the date of birth, then I want you to create a diagnosis flag equal to 1. Otherwise, I want you to flag it as 0. So the diagnosis flag variable is the highly unlikely scenario where a diagnosis is made before the date of birth. It's still possible, but it's extremely, extremely rare. And if I were to come back with the flag of 1 for the DX flag, then I probably should investigate that case. The date difference flags can be used for any other scenario. So you can look at it if treatment was entered before the start of the diagnosis date, any sort of permutation. And it does that because SAS records date variables as numbers. So that's why I can use the less than sign. And then I want to do a proc freak on this new data set, and I want to look at the flag variables I just created. And here's my output. I see that there are 5 patients that were diagnosed after they had died. Okay, that's not too bad. I also see that diagnosis flag is 0 for all patients. So there were no patients that were diagnosed before their date of birth. So now that I know within my data set that there are cases or instances where the actual diagnosis was made after their date of death, I want to do a little bit of investigating further. So what I'm going to do is I'm going to do a proc print on my data set T8, and I put no obs in there. And I am telling SAS I only want you to print the variable patient ID, diagnosis date, and date of death. However, I tell SAS I only want you to print the observations where this condition is met. So only print where the diagnosis date is after the date of death, so the date of death is less than the X date, and the condition of date of death isn't missing. If I didn't have the date of death is not missing, then it would print all the patients who didn't even die because it thinks that the date of death is missing for them. And here's what I get. I start looking at the dates and thinking, does this make sense to me or not? And this example is very possible as postmortem cancer can be made after a postmortem diagnosis can be made. So I look at the date differences and I see a day, a couple days. This makes sense and it's very plausible. The second to last patient was diagnosed about 2 months afterwards, and that could still be possible due to the pathology lab and whatnot. But if this showed me that the diagnosis was made 6 months, a year, or longer after the date of death, it doesn't really make sense to me. And I would need to investigate further and clean a little bit because this would have been a data entry error. So this is a really good checkpoint to see if the dates align and if they make sense. So once I've determined that the dates make sense and I've flagged them, I want to see if the treatment makes sense. So I want to create some treatment checkpoints or some treatment flags. I'm telling SAS, I want you to create a data set and I'm naming it treatment flags. And what I want you to do is I want you to merge my T8 data set, which is my master data set, and I want you to merge information from chemo, surgery, BMT, and the radiation tables. So within each individual table, it will have the different treatment information. So within the chemo table, it has all the chemo information. Same with surgery, BMT, and rad. And I put in the brackets in equals, and that's kind of like a flag almost. So patients that were in the chemo table have that in flag for A. And what I want you to do is I'm going to merge by cyp-c ID. And here I'm creating my treatment flags. So I'm telling SAS, if A, then create a new variable, and I'm calling it chemo, and set it equal to 1. Otherwise, set it equal to 0. And what this means is if the patient is in A, and A is like a temporary name for the original data set of chemo, then create a variable, chemo, and give it a value of 1, otherwise 0. So what a value of 0 represents in the chemo variable is that patient wasn't in the original chemotherapy table, so that means they didn't receive any chemotherapy. And the same principle applies for the surgery, BMT, and radiation variables. And this is really just a flag whether or not they received certain treatment modalities. Now I also want to create a variable, and I'm going to name it the number of treatment modalities. And I want to sum chemosurgery, BMT, and the radiation variables I just created in the lines above. And what this is going to do, it's going to tell me a number, and it ranges from 0 to 4, on how many different treatment combinations that each individual patient had. So a patient with a number of treatment modalities equal to 0 means that they're not contained within any of the data sets of chemo, surgery, rad, and BMT, which means they didn't receive any treatment. And if they have a value equal to 4, that means that they received all 4 treatments. And then I want you to output this information. So I only want the first cyp-c ID, and if I don't have that command there, then I will get duplicate entries. And that's because this is a merge of one to many. So in this example, let's just say in the surgery data table, one patient's in there and may have received more than one surgery, 4, 5, or 6. So they're in there multiple times. Through this merge, it would bring all that information into the merged data set, and then that patient would be in there as a duplicate entry. So I tell SAS I only want the first instance of a cyp-c ID, and what this does is it prevents any duplicates of the merge. And then I want to tell SAS, if master, then output. So what that means is, if any of the observations were contained within the master data set, and if we remember the master data set is assigned to T8, then I want you to output that to this new data set that I'm creating called treatment flags. And that's because the T8 or the master set is really my stem, and that contains my actual patient population. Also, as a little reminder, whenever we do merges, we need to make sure that the data sets involved in the merge are sorted. And they need to be sorted by the common identifier before performing the merge. So here, they all must have been sorted by cyp-c ID. So now once I've created these treatment flag variables, I want to see how the data is actually distributed. So I'm telling SAS, I want you to do frequency output on this new data set I just created, and I want you to create a table for me. And this table is going to be diagnosis group, and then with the star, and then I want it by chemo, surgery, BMT, and RAD. And I put those all in there in the brackets because instead of writing out diagnosis group star chemo, diagnosis group star surgery, it's going to take whatever's in that bracket and apply it to the diagnosis group. And it's going to create for me a whole bunch of 2x2 tables. And by creating those 2x2 tables, I'm able to look at how my data is distributed. So now I see that by diagnosis group, I can see who received chemo and who didn't. And those who didn't receive chemo can be thought of as having missing treatment information because they didn't receive it. So looking at the leukemia diagnosis group, we can see that 107 patients didn't receive any chemo, or chemo is missing for them. Now we need to think to ourselves, while we're cleaning, does this number make sense to me? Did these patients die before treatment, which is very possible, and some of them do, or are they actually missing from that treatment table? Likewise, we look at patients who had CNS tumors, and we see that there's a high percentage of them who didn't receive any chemo. But this makes a bit more sense to me, because this group of cancers can be observation only and not receive any chemo or any other treatment modality. And then I also see SAS will output this frequency table of diagnosis group by surgery now. And I can see that there are 98 patients who received surgery but had leukemia. This is a little bit fishy to me because leukemia isn't really a surgery treatable disease. So were these patients wrongfully included to have surgery? Or could this have been a result of a subsequent surgery that they may have gotten for a secondary cancer? So it's kind of reinforcing the idea of making sense of missingness and determining when it's actually truly missing and not applicable, because these situations are not the same. And then finally, I want to do a cross-tabulation of a diagnosis group by the number of treatment modalities, because it's essential that I understand my data and how the treatment was administered. So in this example, I see that there are 17% of CNS cases which didn't receive any treatment, because that makes sense to me, because as I said, it can be an observation-only disease. But for some of the leukemias or the SNS tumors, to get absolutely no treatment at all, that's going to raise some flags to me. I need to investigate these cases further while cleaning. They should be really separated and looked at more closely. Did they die before treatment could be given, or is it truly missing treatment information? Why are they missing treatment information, and how is the missing data distributed? Is it missing at random, or is it missing because of something else? It's critical to know and differentiate between the missingness and the not applicable, because they're not the same, and it'll influence how your data is handled and ultimately cleaned. So here's a little wrap-up slide of what we covered today. Hopefully the tools and concepts presented will enable you to think critically about your data and how it's distributed and what it really represents. And that'll ultimately inform how you clean it. Thank you.
Great. Well, thank you very much, Giancarlo, for an overview of data cleaning. I guess we'll open the floor up for questions if anyone on the line has questions. Maybe I'll start with a question. Giancarlo, how much time do you think you need to allocate to cleaning a data set?
A lot. So I usually think of, in terms of cleaning my data, the time spent is at least 80% of my research time once I receive the data, because running analyses on a clean data set is a breeze, and it takes, not as nearly as long as cleaning the actual data set. You will spend most of your time cleaning, for sure.
And I guess that's the idea, that you're actually cleaning and also manipulating the data at the same time, right?
Yes.
Yeah.
And then it's a cyclical process. While you're cleaning, you'll uncover something that needs to be cleaned further, and then you might discover something you missed. It's very time-consuming.
Okay. So are there any other questions? Well, hearing none, I'd like to thank Giancarlo for coming out and presenting data cleaning using SAS, and specifically focused on the cyp-c projects themselves. I would like to remind people that this is one of the webinars in a series of talks. I think the next talk is scheduled, let me just check here, sorry. The next talk is scheduled for sometime in September, I guess, September 8th. Where we'll actually have another guest speaker, Charlene Nelson from the University of Alberta, talking about geographic information systems and how you would be able to use the data for those purposes. So we look forward to that talk, and more information will be forthcoming. But at this point, I'd like to thank you all for attending, and again, thank Giancarlo for an excellent presentation. Thank you very much.
Thank you.
Yes, thank you.